In this video, we're going to take a look at using our algebra and trig identity skills to help us solve what looks like a complicated integration question. But if we break it down, we'll start to see that simplifying it before integration can really help us. So what I would do here is I would say that is going to be, if I square that out, I'm going to get the integral of cos 2x, and that's all squared, plus 2 cos 2x times sine 2x plus sine 2x all squared. That, we should know, can be rewritten as cos squared 2x plus 2 cos 2x sine 2x plus sine squared 2x. So all I've done there is I've said, instead of saying it's all squared, I could write it like this. And if you're unsure about that, go back and take a look at the Trig Identities chapters where we would have looked at this notation. Now what I will do is I'll simplify it more. So I'm going to put my cos squared 2x and sine squared 2x together. And I'll be left with 2 cos 2x sine 2x. So what I should notice here very quickly is that if I have cos squared of some angle plus sine squared of the exact same angle, that adds together to give us 1. And that is one of the key trig identities we'll need to remember. It's in the log tables on one of the first pages. You'll need to remember that cos squared of an angle plus sine squared of an angle gives us 1. Now, the next thing I'm going to need to do here is figure out if I can do anything with this 2 cos 2x sine 2x. So 2 cos 2x sine 2x. And if I look in the log tables using my knowledge from trig identities, I will actually see that that can be replaced with sine of twice the angle. Now, what is important here is it's going to be sine of twice the angle, which is already 2x. So it's going to be sine 2 of 2x. And again, if you're unsure of where I got that from, it's in the log tables. And let me check what page exactly it is. It's on page 14 of the log tables that I'm getting that from. So page 14 will be important here. So I've just replaced this part with sine of twice the angle. Now I'm being careful because twice the angle here actually means it's going to be 2x. So what I'm looking for is the integral of 1 plus sine of 4x, which is something we can do. So when I integrate 1, it becomes x all over 1. And then sine becomes minus cos 4x, and we divide it by 4. And then we must remember to put in our plus c because it is an indefinite integral.